My name is Silvia Massetti. I am a Tripoli parts engineer in ESA.
My name is Tony Denham and I'm a components engineer at ESA's Materials and Electrical Components Laboratory.
During the procurement inspection, we usually perform a destructive physical analysis, and during one of these analyses, we found a crack inside hybrid oscillator.
This part was used to provide timing functions for the power control unit.
A failure of a crystal oscillator would mean a complete loss of the equipment. The missions that were affected were Small Geo, Seosat and Bepi Colombo. Any delay would have been a big impact in the overall schedule of the mission.
It was completely unknown whether such cracking would cause a failure at some time during the mission. The obvious thing to do was to either test it or get better parts. The problem was initially investigated by reconfirming the extent of the cracking with microscopy and X-ray analysis to see if this mattered in the life of the satellite.
We identify exactly the same defect that we encountered during the first destructive physical analysis in all the samples that we deleted. Then we selected the worst, and then we submitted them to thermal cycles.
The thermal cycling was made with a thermal chamber which was capable of both heating and cooling the part. It went up to a plus 125 degrees centigrade and was cycled right down to minus 65 centigrade as rapidly as possible because that does the most damage. This thermal cycling reproduces in a shorter time scale the damage caused by thermal cycling of the satellite itself as it goes in and out of sunlight and heats up and cools down.
After the thermal cycles, we observed that no evolution of the crack and of the defect have occurred. The happy ending was that we saved 52 weeks and we were confident that the batch was operating properly. The final outcome for the mission is that the mission respects the schedule and now they are integrated in the satellite.